Yeah, happy to be here, and yeah, let's just dive into it. You already mentioned my title. I hope you're all in the right session. And yeah, just a quick intro to myself. I'm Lea. I'm a data scientist and data product manager at Innovex, and we also have a booth here, so if you want to talk to me or other of my colleagues, just come around. As Max already mentioned, I have a PhD in behavior economics. Back then, I was really interested in biases and human decisions in economic context, but now I'm more interested in how these human biases actually crawl into our models and data products. And there are also some other topics I'm really interested in, and in my free time, I enjoy doing all sorts of sports. Yeah, so I guess you have seen these kind of things before, AI gone bad, how I called it, and there are lots of headlines you've seen where algorithmic decisions are taken under this kind of veil of fairness. So because they're done by a machine, they have to be objective, they have to be fair, but actually we saw that there are some things which went wrong, and there's a whole database for all these kind of incidents, and there are situations where you actually maybe shouldn't have built the thing in the first place, and maybe shouldn't use an algorithm for it, maybe also in a context where this is not really going right. There was this outcry in the UK when they used an algorithm to kind of predict the grades for the A-levels, and well, the algorithm in itself wasn't really wrong, or the model wasn't wrong, but the objective was maybe wrong. There were some biases baked into the algorithm, so it didn't go out well. So there's also lots of examples. I guess you've seen some of them, and if you're interested, just check them out. So I hope this is motivation enough why we should care about this, and what we should care, just like for a big wrap-up, for what kind of dimensions we have, and what facets of data and AI ethics or responsible, trustworthy AI, they are all terms that are kind of used interchangeably. I took kind of 4 things from the Turing Institute just to wrap your head around it. So fairness, first of all, is a really important notion. So non-discrimination, equitable input and outputs, which then leads to unbiased implementation. I know it's kind of a vague concept, and oftentimes it just depends, so it's kind of context-specific how fairness will really look like, but it's still something you should wrap your head around in the very first place. Then accountability, of course, is quite important, and I would guess it will become more important with the EU AI Act, and where auditing is necessary, and you really need to answer questions about how your model is taking decisions, what factors are counted in, and that we have humans in the loop across the whole process, from inputs to outputs. And even though automation is cool, sometimes there should be a human having some oversight and review of the things there. Sustainability, of course, there are I really like this term of that data products are socio-technical, so they really don't exist on their own, but we as people, we interact, and they have real-life impacts on us, and so they have transformative effects, and there are decisions which are taken with algorithms, so people get a loan, get a job, get the admission to a university, so they really have impacts on society and how we proceed in life. And safety is the last point here, which obviously is also really important. And then last but not least, transparency. So really need to be able to explain. There's lots of efforts also to document what you have, how your algorithm works in a way that also the kind of general public understands it. And you really need to be able to prove that what you are doing is ethical. And as I said already, it's also something which will become more important. I took this from the Turing Institute. I like this acronym FAST, so it's something you can remember, but of course there are also different dimensions from different sides, but I think it captures quite well what we should care about. And so now, now, since we settled the grounds, I want to dive into my actual content. So I want to look into the life cycle of a data product. So I guess many of you have seen this before, and I want to go through each step and look where biases crawl into here and what could go wrong at each stage. So since time is short, I will really dive into the business understanding. This is the first part, and this is actually before we have written the first line of code. So it really, this is the question of whether the product should be built in the first place. So really think about what's the purpose and the need behind the product that you want to build, and whether the outcomes could have negative effects on society or particular groups. So this is really important, that even if by large it might have positive impacts, there might be groups which are suffering because of what the product is doing, and so it could be a way to reinforce or reiterate discrimination, past discrimination, which comes from the data that is already biased. Also thinking about the stakeholders, do they have implicit assumptions? Are they actually valid? Do they have biases or blind spots? And then looking into the kind of KPIs for a product, how will the performance be evaluated? How will be defined that the product is successful in the end? And so these are the things that you should really think about, and there are ways to kind of structure your thinking about it. So in general, I think it's really important to always look at the big picture to understand the main goal. By this, you can do gather background information, talk to the main experts, really try to collect diverse views and expertise. Microsoft has this responsible innovation toolkit, which I quite like. They have certain frameworks and activities which can put you in a place to really look into these into a product from different sides, and kind of really write down what kind of potential risks there are. Also do maybe interviews with different stakeholders you haven't done before. This is also, it's not only to be ethical, but actually also, I think, to build better products in general. There are also self-assessment tools, and as always, it's really important to really speak out, communicate concerns and risk, and discuss about it. So this would be the first stage of the product life cycle. And if this is already said, we would dive into the data, look at the data, and here, of course, informed consent is a very important factor. So are you actually allowed to use the data for what you want to use it for? So nowadays, there was quite some discussion about it. We know that ChatGPT was banned in Italy because of that, because they use oftentimes data which is available on the internet, but is this really informed consent of the people that are providing this data? Then what is really important to understand how the data is generated. What is the process? Is there already maybe some kind of biases within the data generation process? So where do they come from? How are they generated? It really makes sense to really look also on the other side. So for example, if it's human-generated data, how does the process behind look like? Are there missing things which affect the data quality or how data is structured? And of course, if also for labels, if you use labels for your data for supervised learning, really look into how are they generated. If they're human labeled, there's quite a high risk that there are also some kind of biases involved here. So really ask yourself who did it, where was it done, when, and what for. Training data, of course, should be representative of the target population. Sometimes it's really hard to find out how your target population looks like, but really check for distributions and look whether it's representative. Data quality, I already mentioned, are there systematic deviations in the quality? So are there systematically missing values, wrong values, these kind of things? And also one important thing, do we actually induce bias within our data preparation process? So I will also discuss it in the next slide a little bit more. So how do we actually process the data? Do we discretize certain values? This might affect also the distribution of the data. So a good start is to start documenting your data sets. even though it's just a documentation kind of thing, but it really helps you to get a structure and ask yourself a lot of questions you might not ask yourself beforehand. Check for the privacy of protected attributes. There are different methods to do that. I don't want to go into detail here. And of course, I guess we all know that EDA is important, but really do it thoroughly. So really check the distribution and quality of your input data. As I said, the representation of different groups, events, and so on. What is the data quality distribution across the whole data set, but also for different subgroups. Are there systematically missing values? And there are lots of tools out there. I just put this one here, where you can really easily visually inspect your data and check for deviations, outliers, and these kind of things. Then check for the impact that your pre-processing efforts actually have. So maybe you remove observations with missing values. This can have a strong impact if there's some system behind that. Also, when you impute values, this can really affect these kind of things. And once you realize there is a problem with the data, it's maybe imbalanced, there are also some methods to actually correct for this with reweighting over undersampling and so on. Okay, now we have our data set. We can actually go to the data modeling part. So here, really think about what are the underlying mechanics and assumptions of the algorithm, which are the metrics you're optimizing for. Are they really, is it feeding into your final goal, or are we maybe also trading accuracy for explainability? When you use pre-trained models, which is quite popular right now, really think about the initial context and the intended use. This also always comes from the data, so what kind of data is used to train these models? Does it actually reflect your current use case as well? And within your model, are you using sensitive attributes? Or actually, it's quite important, I should have put this in bold, actually, or any of their proxies, because some of the features are quite straightforward, that they can be discriminatory, but it's even more risky if you use any proxy. So maybe postal code could be a proxy for a certain ethnicity, and if you use this in the first place, it might not look like it's anything really sensitive. But this can really bias your model, and in this way, it's way harder to detect. So oftentimes, it makes sense to actually have those attributes in place and then be able to detect and correct for it. And then, are the outcomes of your model fair and unbiased? Are specific groups discriminated against? So how do we approach this? So in a sense, I guess it's nothing new, but it's always good to start with simpler and explainable, more glass box models approach, where you can really understand what are the mechanics, how does the data look like, what different features, what kind of effects do they have. Also, I really like this kind of more mathematical modeling approach, where you start with the domain knowledge, you check what is actually at hand, what is taking place in the real world, and try to put this into mathematical language and into a model, and then go ahead from there. And of course, there are also lots of interpretability and explainability methods out there, feature important analysis, where you can find spurious correlations, which can point you towards these kind of proxies I was talking about. Integration of fairness constraints is something you can also make sure that maybe you already, within your training, you already optimize also for fairness, or put constraints in there. And once you've done that, you also should check for these kind of heterogeneous effects and disparate impacts. So it's kind of, again, about those subgroups. Also check for interactions. You might be seeing that there is no effect on race or gender, but maybe if you interacted, that maybe black women are actually discriminated against or something like that. So this is also important to be aware that different combinations might be affected. And this is especially when they are small, like they reflect only a small part of the data, and then there's essentially a high risk that there's something wrong here. And once you find that there's a bias, there are also some bias removal strategies you can put here. It's hard to really generalize, but you can check it, and you need to find the right tool for your use case and for your model. And there's some, I just put the IBM Fairness Toolkit here. They have lots of these strategies implemented, some metrics as well, so it's a good way to start using these kind of metrics as well. Okay, going to the evaluation, so it's somehow related, but first you have your model, you try out different things, you already evaluate about it, but then once you you have chosen your model, you also want to evaluate it with respect to not only the machine learning metrics, but also more like the business side KPIs, and this is where, we should ask ourselves whether we are using appropriate and fair performance metrics. Are there any trade-offs that we can see that we are, we are seeing in our models? And I can't repeat it enough, but really, does the model performance vary across subgroups? We have seen some examples where I think it was in Facebook they saw that their facial recognition algorithm really performed really badly on black people, but now they actually report it on their site. They put some model cards out there and really report how they perform, and I think they managed to get it across equal performance around. Then not only what does your model say and how is performance of your model, but how are these results interpreted and communicated? So I guess many of you have heard about confirmation bias. Oftentimes, we just want to confirm our previous assumptions, and we really need to challenge ourselves for that as well. And when there are problematic factors, they should be are they really transparent, and are they pointed out maybe in the documentation, but also when you present results, of course, to the business. And what are the tools or approaches we should take? So of course, make sure that also the test set is balanced and representative, that the model performance reporting is really differentiated, so really rather use an ensemble of performance metrics, which makes sure that you also see these kind of trade-offs that I was talking about. Disaggregate and slice-based evaluation. There's also tools for that. And really also make sure that you use a combination of quantitative and qualitative measures, because like looking into the data, checking for certain use cases, certain personas, and how the model behaves is quite important. And certainly quantification, especially when it comes to subgroups which have really small representation, there's a high risk that the results are somehow really overfitted and somehow uncertain, and then you should actually try to also make this transparent. You can integrate fairness measures, and in general just really stress test your model, check for different situations, so really know how your model behaves and communicate those kind of uncertainties, risks, and trade-offs. So then we come to the last part for the deployment and monitoring. So once your model is ready and evaluated, we want to put it into production. And this is actually the last step where you can check whether ethical requirements are fulfilled. Obviously, you should really care about this already beforehand, but this is the last chance you have for that. And you need to check whether your data is stored in a protected and secured place. And once it is in place, it's actually quite important that we also monitor future performance. So we are not done here. The model lives then, and data change, and so there might be biases get introduced into the model, and whether they will be detected and will be able to correct it again, and whether we would be able to track back the source of the bias. And there's some tools. So again, it's a checklist. Of course, it's always only as good as the usage of it, but there are some ethics checklists from Dion, which you can actually directly implement into your repo. You can make it really easy to make these requests and requirements transparent. Model cards is also something, I would believe that it will become a standard in the future to really report what the model is doing, what data you're using, what are you evaluating on, so really make it transparent. And then, the last part is mostly general MLOps best practices, so performance monitoring, really check the quality distribution of input and output data, and track performance, and you can just use these tools also for fairness metrics and monitoring how you perform on different subgroups and so on. And of course, yeah, ensure reproducibility. But this is something which I guess is best practice, but also important when you think about fairness and biases. And yeah, human in the loop, I already mentioned, is something also quite helpful, so not automate everything, so really check on a regular basis how you're performing. Okay, so yeah, I'm at the end of my talk, so some takeaways. First, it's a really broad topic. The resources can be quite overwhelming, I can tell from experience, but just start also bringing the topic into the table because we need this awareness and it's a prerequisite, and because if you don't see it, we can't fix it. As you've seen it, there's at every stage of the life cycle there can be biases introduced, so make sure that you are aware of that. There are lots of tools that you can use for that. You need to find the right tools for your use case, but there's a lot out there, so make use of it. And of course, start the communication, bring these ethical concerns to the table, really discuss with stakeholders about this, and speak up. And because, yeah, it's my personal opinion, but I think we as data professionals have a responsibility here, and we should comply to it. Yes, so thank you very much. If you have any questions, I'm happy to answer them. Right on time, actually. So yeah, I'm happy I stick to the time. I could actually talk for hours about this topic, but yeah, I only signed up for a 30-minute slot. So.
Thank you, Lea. That was a really interesting and informative talk, and I think especially nowadays, this is a really big question, and I'm glad that you're out there trying to help people answer that question, so thank you. I do have just a few questions for you. So the first one I've got here comes from Aoife, who asks, how do I know the intended use for data collected in LLMs? How do I know what the intended use is?
Yeah, I think it should be actually documented, these kind of model cards. So especially for release models, I think it's something very important. If not, I guess it's something where we should also get into contact and maybe actually ask for this, because just because everyone uses it, it's not something you should just use straight away. So yeah, we should read the manual.
Read the manual.
Yeah.
Awesome. Okay, I've got just a few more. And a few coming in as well. Let's see, so I'll just ask you this one. So just a quick question here. Is there such a thing as good, unbiased data?
Yeah, that's a difficult question, and I also already pointed towards it, because fairness and representativeness is really hard to define, maybe representativeness more. I guess there's not really unbiased data, but you should be aware, and you should see, and yeah, try to take measures to make it more suiting to your kind of fairness notions, and yeah, maybe censor data, I don't know.
Sure. Thank you. There's a few more coming in now, actually, so we've got a few to ask you, if you're okay. If you're
I'm
okay.
fine.
If we don't get to your question, by the way, Lea will be around for the rest of the conference and at the Innovex booth as well, so you'll be able to find her. But for now, I'll just ask you, is there a list of minorities that are maybe, or are there some minorities maybe that are discriminated against more commonly that maybe we need to be aware of, that like maybe aren't as known, like maybe there's a group that maybe you're not aware of?
I have never seen like a general list for it, but I guess it's things that we see a lot is gender, age, social background, ethnicity, obviously, religion, these kind of things. So these are the most straightforward, but there might be other groups, and they might be also particular for your use case. And yeah, I would say the more you have a broader picture, the better.
Awesome, okay. So keeping going, we've got a few more. This is popular talk, lots of questions. So the next question is, have you got an example that you can share for a fairness constraint? And how do you make sure that a fairness constraint does not include any bias?
Yeah, so I guess quite straightforward example would be that when you have, I guess, facial recognition software or something where you see that it should be, like the constraint could be that it should be equally, or like the deviation between performances across different groups shouldn't be too large. So we should make sure that even if there are smaller groups, we also perform similarly well, because if there's actually a minority, it might get fed into, if you just look at the average, you might not even see that performance is quite bad for this particular group.
Awesome, okay. And a question here from Christian, who asks, reweighting data sounds nice, but that's only possible once you already know the bias. And is there a general data sanitation approach that you might take to avoid biases?
Well, as I said, there's not really a general one to avoid biases. I think it's something, as I said, also you need to consider in every step. And reweighting is something, I think, for example, in survey data, they do quite a lot to get a representative sample. So oftentimes, if they do surveys, there is some kind of imbalance towards certain groups, and then they kind of just reweight certain observations. But of course, it's also tricky if you don't have this knowledge about what is actually the target distribution, whether you have those features actually which allow to track back these kind of features as well, so like attributes of certain subgroups. So yeah, it's hard to say there's a general approach, but yeah, just be aware in every step and think whether there is some bias get introduced here.
Yeah, I think that's what I took from your talk too, and that it's important at every stage just to be really pragmatic and really work out what you can get from this kind of following this process. We've got a few more just coming in last minute. So there's one here. Do you think some organizations can have incentives to exploit and exacerbate biases? And if so, how might we deal with that as a community?
I definitely think so. I think we're currently seeing it a little bit. So being the first one, being the fastest one might actually want you to skip these kind of considerations. And we have seen there are some examples where people get fired because of that, and economic incentives are more in the forefront. But in the long run, maybe just regulation can solve this issue, because and I think there are some initiatives about it. I'm not sure, or still looking forward to see how this really affects these kind of companies. But it's really hard to balance these kind of incentives which companies have and these kind of ethical concerns. But that's why also we as individuals should take our responsibility as well.
I think that's fair, especially given that if you've come to a talk on data ethics, you're probably someone who has an interest in that area and maybe is in a position to really think about where you're at with that. Just a couple of questions. We've got just a minute left, so maybe I'll just ask the last one I've got on here. Would you rather not build a model if there's no good data? Would you rather not build a model rather than building a bad model? Where is the balance, would you say? And I think that's going to be our last question. I'm sorry, I know there's some more coming up.
So happy to also discuss this topic later on. It's a tough question to really answer in general terms, but we've seen it with this kind of grading algorithm in the UK. I think a bad model has more harm than no model, because of course people have biases too, but in a sense, mostly it's more likely that people have different biases, and there is no general discrimination against particular groups. But if you have it baked into a model, it kind of is really systematic and reinforces itself. So I would be torn towards not building the model in the first place.
Sure. Well, thank you very much, Lea. It's been a really awesome talk to So can we just give Lea another big hand before we go?